As we begin to try to match these graphs, this is another section where you cannot get these wrong. It'll let you keep trying until you get them, but I'm going to work one or two to help you get the gist of it. First of all, this is a sine graph. I can tell it's a sine graph because it starts at 0 like a sine graph should. It has a maximum of 1, and it goes ahead and it has a period of 2 pi. So this is just a standard sine graph is what they've graphed for you in black. And in the dotted line, they've changed this sine graph a little bit. In this case, they haven't changed it much. It looks like they've just slid it down. So remember, the phase shift comes at the end of the problem to do a vertical translation. A vertical translation or a midline change. Shouldn't have said phase shift. I would need to go down by 2. And then I can just click try. And since it looked like they moved the graph down 2, it turns out we're right. And then you got that correct and you could submit. We'll go ahead and look at another one. Okay, and this one, they've started us off with a standard cosine graph. I know that's a cosine because it starts at 1. And I know it's a standard graph because it also has a period of 2 pi. It takes 2 pi to complete one cycle. But anyway, for this cosine graph, what I would need to do is I would need to first of all, worry about the vertical shift or the midline. So the vertical shift, it looks like currently the midline's at 0, and it looks like I should make it so the midline might come to about 1 or 2. So if I try a midline of 1, it's gonna slide it up a little bit, but I'm like, hey, I'm pretty satisfied with that. It looks like that, it really is centered around 1. It's kind of balanced around 1 like my other graph is. But now I have the issue of it not being stretched enough. So now I would adjust your amplitude second. So I go from 1 to 4. That's a distance of 3. So I'm going to try an amplitude of 3. The vertical stretch or the amplitude is the number in front. I try it. And then that gets it to you. I would recommend going through these in that order. First, worrying about your vertical shift or your midline, then worrying about your amplitude. Okay, this is a sine graph. It looks like in this case, the dotted line, my midline is still going to be 0, so I don't think I'm going to need to adjust anything. The way I know that is if I'm going from 4 to -4, the number in the middle of 4 and -4 is 0, so it's already balanced. Now I need to worry about my amplitude. From 0 to 4 looks like a 4, so I'm going to try a value of 4 and see if that fixes it. And what I'm going to see is it does give me the amplitude that matches, but it looks like my graph needs to be flipped upside down. So remember, putting a negative in front of the graph will flip it upside down. And once again, you could keep trying different things until you eventually got it, but that's how you do one of these. Okay, we're always going to start by adjusting for my midline. So this goes from 4 to -2. So the number in the middle of that is 1. So the first thing I need to do is adjust this graph so it has a midline of 1. So I'm going to put a 1 there. I'm just going to go ahead and try. And it looks like, hey, that's balanced. It's in the middle the way it should. Next thing to worry about is my amplitude. So from 1 to 4 is an amplitude of 3. And remember, the amplitude is a vertical stretch, so it goes out in front. I can try that. And now, once again, I'm going in the wrong direction. Instead of starting at the top of the graph, I need to start at the bottom of the graph. So the way to do that is to flip this thing vertically by putting a negative in front of the 3. And this is a good example of how if you had a situation in the real world that started at a minimum instead of a maximum, putting a negative in front would make that cosine. Start at the minimum first. So that gives you some ideas on how to write some of these equations.